AI Research News Update by MarkTechPost.com.
Every bit of data that goes over the internet, from paragraphs in an email to 3D images in a virtual reality environment, is susceptible to noise, such as electromagnetic interference from a microwave or Bluetooth device. The data is encoded so that when it reaches its destination, a decoding program can reverse the effects of the noise and recover the original data. A group of researchers from MIT, Boston University, and Maynooth University have created the world's first silicon chip that can decode any code with maximum accuracy, independent of its structure. The team employed a universal decoding algorithm called Guessing Random Additive Noise Decoding (GRAND) to create this chip. GRAND offers enhanced efficiency by reducing the need for several computationally complex decoders. This novel chip has diverse applications in augmented and virtual reality, gaming, 5G networks, and connected devices that need processing a large amount of data with minimal latency. Noise or energy that disrupts the signal is often generated by other electronic devices, and it affects the encoded data as it travels through a network. When the encoded data and the noise that influenced it to arrive at its destination, the decoding algorithm typically consults its codebook and guesses the stored information based on the hash structure. On the other hand, GRAND works by predicting the noise that influenced the message and then deducing the original information from the noise pattern. GRAND creates a series of noise sequences in the order in which they are most likely to occur. It then subtracts them from the received data and verifies whether the generated code word is in a codebook. Even though the noise appears to be random, it has a probabilistic structure that allows the algorithm to guess what it is. GRAND architecture. The GRAND chip has a three-tiered structure. The first stage starts with the simplest feasible solutions and eventually progresses to longer and more complicated noise patterns in the subsequent stages. Each stage works independently, increasing system throughput while conserving energy. The device can also effortlessly transition between two different codebooks. It has two static random access memory chips, one of which can crack code words while the other loads a new codebook and immediately switches to decoding. Because GRAND only uses codebooks for verification, it can be used not only with historical codes, but also with codes that haven't been released yet. Therefore, GRAND may be able to eliminate the requirement for such strict standards in the future. The GRAND chip was tested and found to be capable of decoding any moderate redundancy code of up to 128 bits in length with only a microsecond of latency. The GRAND chip, according to the experts, might even spark a surge of innovation in the world of coding. In future, the team plans to use a retooled version of the GRAND chip to tackle the problem of soft detection, in which the received data are less exact. They also intend to evaluate GRAND's potential to crack longer, more complicated codes and tweak the silicon chip structure to increase its energy efficiency.